Yes! We finally did it, guys. We got into chapter 1. Ugh. Just took us 20 years. So lesson 1, variables and expressions. So we've got some definitions to start out the lesson with. What is an algebraic expression? It consists of sums and or products of numbers and variables. What's a variable? They're symbols used to represent unknown values. And then what is a term? A term is a number, a variable, product, or a quotient of an expression. So for example, that right there, that thing, is an expression. So what we're going to do is we're going to take this expression and we're going to write it verbally. And I cannot handwrite these sentences to save my life. So I'm going to type them. So this says 3 times x to the 4th power. That's verbal. Ooh, that was way too quick, computer. Next one. Apparently I need to change the color first. Let me try that again. And there goes my cat knocking stuff off. Cool. I have 5 times z to the 4th power plus 16. I can spell really good sometimes. Next one, I have 16 times u to the 2nd, or times u squared, minus 30. And my last example, I have 1/2 times a plus 6 times b divided by 7. That's that first part. Not too terrible. Just taking numbers and putting them into words like we talk. You're going to need to really write this chart down. Trust me, you're going to want to write that chart down. So words that mean addition or we're adding, more than, sum, plus, increase by, added to. Subtraction is less than, subtracted from, difference decreased by, minus. Multiplication is product of multiplied by, times, and the word of. We saw that of when we did percents. And division is quotient of or divided by. So we're going to write an algebraic expression for each verbal expression. So these ones are a little bit harder. Sorry. A number t more than 6. So I don't know what my number is. It's some kind of number. So it's telling me I'm going to use a variable t. And I'm going to use the number 6. And the word more than, the phrase more than, is right there. So I'm going to add them together. So it's t plus 6. This next one's not very easy, I'm sorry. 10 less than the product of 7 and f. So I know this less than means subtraction, because it's right here. So I'm going to have subtraction. And I know product of means multiplication. But what am I multiplying? Well, I'm multiplying the 7 and the f. So I have 7 times f. And I can just glue them together. But I have 10 less than the product of that. So I'm going to take 10 minus this guy. I'm going to have this. Or would I have this guy minus 10? Well, let's try an actual concrete example to figure it out. Let's pretend we're talking about the numbers 35 and 25 because they're 10 apart. If I wanted to say that 10 is 35, 10 less than 25, I'm pretty much just using these words and sticking it in the middle. Is 3510 less than 25? No, it's more than. So since that doesn't make sense, I'd have to say that 25 is 10 less than 35. Yes, 25 is 10 less than 35. So I know it sounds backwards, but I promise you that one's my answer. Don't hate me. I know that was a big discussion in class, so I'm sorry. Next one, 2/3 of the volume V. So 2/3 is simply a fraction. The val of means multiply, and then it tells me the volume is going to just be the letter V. So that one wasn't that difficult. That one wasn't as hard. It wasn't as challenging. Okay, same directions, new problems. I have, what, 2 more? So the product of P and 6, so 6 times P or P times 6, so 6P. And 1/3 of the area A, so 1/3 times the area value, which is A. Ooh, word problem. We always love word problems. Mr. Martinez orders 250 keychains printed with his athletic team's logo and 500 pencils printed with its website address or website. Write an algebraic expression that represents the cost of the order. So I'm going to right away and say, bam, C is equal to cost. Well, what else is important? What other key ideas are in here? Let's look. Mr. Martinez orders 250 keychains. Okay, well, we're talking about the word order. So maybe 250 keychains is kind of important. And that's printed with its athletic team's logo. That really doesn't tell me anything about the cost. If I'm asking for the cost, that's not going to help me. Let's keep going. And 500 pencils printed with its web address. Ooh, maybe the 500 pencils, that might help. Yeah, web address doesn't matter. And then I'm back to the directions of what I'm supposed to do. So I have keychains and pencils. Well, I don't have keychains in front of me, but I do have a pencil. This one pencil would cost a specific amount. So if I made 500 of them, wouldn't I simply take the price of 1 times 500? And wouldn't that then be the cost of the amount of pencils? Man, if only I had a way to represent, oh wait, I do. I could let the letter P be equal to the price of my pencils. Because pencils start with the letter P. But I also have to get keychains too. Maybe I could do K for keychains. What a world, right? So the cost is equal to 500 pencils, the cost of 500 pencils, plus, how many keychains am I buying? Oh, that's right, 250. 250 times the, and that 0 did not look good, times the price of my keychains. All right, Katie bakes 40 pastries and makes coffee for 200 people. Write an algebraic expression to represent the cost of the situation. And I meant to underline. So cost, what's important? Probably the pastries and the people. Poop, those are the same letters. So what else could I do? What about coffee? Oh man, that represents my C2. Well, at this point, that's okay, because I could use a T for total, because that's another word for cost. I don't want to use the same letter too many times, because then I'll get really confused. So I'm going to let T be the total. Let's say P be the pastry price. Oh, computer, you're very frustrating. And we can say C equals the coffee price. So my total is equal to 40 pastries plus 200 coffees. Bam. Have a good one, guys.